Here is a problem that utilizes a variation of Charles' law, which represents the relationship between pressure and temperature. So we got to convert this to Kelvin. So 273 plus 25 is going to be 298 Kelvin. At a pressure of 0.80 atmospheres, 0.800 atmospheres, is contained in a glass vessel. Suppose that the vessel can withstand a pressure of 2 atmospheres. We're going to call this P2 and call this P1. How high can you raise the temperature? We're going to call it T2 of the gas without bursting the vessel. So if it can withstand a pressure of 2 atmospheres, let's go ahead and get this to all the way to 2 atmospheres. By Charles' law is at P1 there's going to be a temperature T1. We suddenly change the pressure or the temperature. If we change the pressure, we will have a new temperature. We change the temperature, we'll have a new pressure. That's symbolized by P2 over T2. So this is a Charles' law problem. So we have our P1, we have our T1, we have our T2 that we want to solve for. P2, yeah, let's just get it all the way, before this thing bursts or on the verge of bursting, and we'll make our P2 2 atmospheres. So let's go ahead and solve this problem. Right, so we have P1 over T1 is equal to P2 over T2. This is kind of like your before condition. This is kind of like your after condition. So your P1 here given to us is 0.800 atmospheres. Our T1 is going to be 298 Kelvin. Very important you convert it to Kelvin and all these problems. And then we're going to get it to its limit, which is 2 atmospheres. What is the temperature we need for it to get to its limit? So our P2 here is 2 atmospheres. And our problem asks us to solve for T2. We can cross multiply, but it's going to be 2 atmospheres times 298 Kelvin divided by 0.800 atmospheres. And then the atmospheres cancel each other out. So 2 times 298 divided by 0.8, excuse me. And I'm getting 745 Kelvin. You got to get this to about 745 Kelvin, which is approximately 472 degrees, right? Minus 273. So raise this temperature up to 745 Kelvin. You have a pressure of 2 atmospheres, and remember, increase the temperature, increase the pressure, and that's just on the verge of having this this vessel sort of burst.